Hello everyone, welcome to my channel Study at Ease. Today we are going to start with the CBSE Grade 10, the first chapter, which is the real numbers. What are real numbers? Real numbers are a set of numbers which includes the natural numbers, whole numbers, integers, rational, irrational, etc. The Euclid's division lemma, it says, given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where 0 less than or equal to r less than or equal to b. Now if you see this, you can understand that a and b are the dividend and the divisor, and q and r are simply the quotient and the remainder. Now we know remainder will always be less than the divisor and can even be 0. Euclid's division algorithm. It is a technique to compute the highest common factor, that is the HCF, of two given positive integers. Let me tell you, this Euclid's division algorithm is derived from, or it is based on, the Euclid's division lemma. Now, to understand more about the division algorithm, let's have a look at one of the example questions. So, let us take an example from the textbook, that is the NCERT Grade 10, Chapter 1. It is taken from exercise 1.1 and it is the first question. The question says, find the HCF of 135 and 225. Step 1. Compare both the numbers, that is 135 and 225. Step 2. Now we are going to divide 225 by 135. So we're going to write this in the form A is equal to BQ plus R. So here it becomes 225 is equal to 135 plus 90. In this case, since the remainder did not become 0, it is still 90. So we're going to apply the Euclid's division lemma again. So here it becomes 135 is equal to 90 multiplied by 1 plus 45. Here again, the remainder is not 0. So we need to apply the division lemma again. So here it is. 90 is equal to 45 multiplied by 2 plus 0. As you see in this case, the remainder has become 0. So the last divisor, which is 45. Now we can see that the HCF of 225 and 135 is 45, which is the last divisor. Let's move on to the second question. It is also from the textbook NCERT Grade 10, Chapter 1 and Exercise 1.1. Now, what does the question say? The question says, show that any positive integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some positive integer. Let us write the general form, that is, A is equal to BQ plus R, where 0 less than or equal to R less than B. Let A be any positive odd integer. How did I get that? I took it from the question. It says any positive odd integer. So I'm just taking it from the question. So let A be any positive odd integer, and B, it is also given in the question. Can you see 6q plus 1, 6q plus 3 and 6q plus 5? So B is 6. So when A is any positive odd integer and B is 6, R should be in the range 0 and B, right? So it becomes 0, 1, 2, 3, 4 and 5. It cannot be 6 because R cannot be equal to the divisor. Now let's move on to write the form. That is in the form A is equal to B cube plus R. So A can be 6Q plus 0. Then A is equal to 6Q plus 1. A is equal to 6Q plus 2. Then A is equal to 6Q plus 3. Then again A is equal to 6Q plus 4. Finally A is equal to 6Q plus 5. So it says A is any positive odd integer. That means it cannot take the values like 6Q plus 0, 6Q plus 2 and 6Q plus 4 since they are both divisible by 2. So we have to ignore those numbers. So that is A not equal to 6Q plus 0, 6Q plus 2, 6Q plus 4. So any odd integer is of the form 6Q plus 1, 6Q plus 3 or 6Q plus 5. The next question, again, I'm repeating, this question is from NCERT textbook grade 10, chapter 1, exercise 1.1. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? As you see the second line, we get a clue that the two groups should have the same number of columns. So that means we have to find something in common. So let's find the HCF. So we have to find HCF in this question. So according to the Euclid's division algorithm, 616 is equal to 32 multiplied by 19 plus 8. Now 32 will take the place of the dividend and 8 will take the place of the divisor. So it becomes 32 is equal to 8 multiplied by 4 plus 0. So in this case, the remainder has already become 0. So 8, which is the last divisor, is going to be the highest common factor between 616 and 32. So let's write the HCF of 616 and 32 is 8. So there is supposed to be 8 columns. The maximum number of columns is 8. So let's look at the next question, which is the fifth question from this exercise, which says, use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. So this is a bit tricky question, so let's see how to do this question. So as always, let's take A is equal to as any positive integer. So A is any positive integer. So what will be B? In this case, we are taking B as 3. Why? Because you can see this 9, right? 9m, 9m plus 1, 9m plus 8. So 9 is a number. If you multiply it with 3, you're going to get a perfect cube. So we are taking B is equal to 3. Okay. So the next step, what is a form? What is the general form of the division algorithm? It is A is equal to BQ plus R, where 0 less than or equal to R less than B. So we're going to write it in the general form now. So A is equal to 3Q plus R, where 0 less than or equal to R less than or equal to 3. That means R has the range from 0 to 2, not 3. Why? Because it is less than, not less than or equal to. The next part of this question, we are going to consider 3 cases. Case 1, when R is equal to 0. Then A is equal to 3Q. So A cube, what is it? A cube is equal to 3Q the whole cube. So which is equal to 27q cube. Now 27q cube, you can write it as 9 times 3q, which is equal to 9m. That means this 3q, I'm replacing it with a term m, where m is any integer equal to 3q. In case 2, a is equal to 3q plus 1 because the remainder could be 1 in this case. Then a cube is equal to 3q plus 1 the whole cube. Now a plus b the whole cube. What is the formula? A plus b the whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. We are going to apply that identity in this case. Let's apply the identity. Then it becomes 27q cube plus 27q squared plus 9q plus 1. Now in the first three terms, if you see, you can take the 9 common out. Then what does it become? 9 times bracket 3q cube plus 3q squared plus 1q. Bracket closed plus 1. Now the whole thing, that is 3q cube plus 3q square plus 1q. We can replace it with another term m, where m could be 3q cube plus 3q square plus q. So the term becomes 9m plus 1. Now, last but not the least, let's look at the third case. In the third case is when the remainder is 2. So we write it as a is equal to 3q plus 2. Now again, a cube will be 3q plus 2 the whole cube. So we have to consider the identity. What is the identity? A plus b the whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. So let's apply the identity right now. So what do we get? We get 27q cube plus 54q square plus 36q plus 8. Now from the first three terms, let's take out 9 common. What does it become? 9 times, bracket open, 3q cube plus 6q square plus 4q, bracket closed, plus 8. Now again, what are we going to do? We're going to replace the term inside the bracket with a variable. So let it be m. So it becomes 9m plus 8, where m is equal to 3q cube plus 6q square plus 4q. So we can summarize by saying that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. So that's the end of the session. If you have any suggestions or if you want me to teach any particular topic, please feel free to put your valuable comments in the comment section. Now the next session will be the continuation of this topic with exercise 1.2 from the chapter Real Numbers. So please do check out that also. Do not forget to like, share and subscribe my channel. See you in the next session. Bye.